بەناوی خوددا بەخێر بێنەوە بۆ وانەکانی C++. جەشنتان پیرۆز بیت. هیوادارم کاتێکی خۆشتان بەسەر بردبی. In this lecture we are going to talk about the array. Let's describe an array. Actually, the array is a data structure used to store a fixed size sequential collection of elements of the same data type in contiguous memory location. What does mean? It means in the array we are dealing with the group of data, and this group of data also we can access individually if in the each elements, or we can deal with it as a group of the data. But the condition is the data should be at the same data type. Looking to the these data, as you can see here, this is a group of the data. It's a score or of marks, 20, 30, 75, 50. This is a group of data. Individually, they're same type. Both of them, most of them, sorry, are the numbers. And so this is the data is the same type. How it is accessed or describing the indexes, which is very important in the array. Here 20, if we talking about the 20 its element is 1. The element is 1. So the element 1 or first element of this array contains 20. But the index of this 20 is 0. If you remember, we previously talked about the index. So the index always starting from the 0, 0, here 1, here 2, here 3, and so on. So this is the index. At the bottom is the index. At the top is the element number. In the programming, we are dealing with the indexes. So that's why here I stated the elements are accessed using a zero-based index. The basic syntax of declaring an array is the data type, I mean integer, float, and so on. Array name, what's the name of the data you are proposed, and then finally, sorry, the array size. The array size means, so if you again come back to this example I talked about, so we have 20, 30, 75, 50. It means 4 elements, 4 elements. So 4 elements would be array size, array size. So this is the size of your array. Let us know how you can declare the array. Actually, if you looking there, what we mentioned in the previous slide, we said, just if you go back, data type, we said data type integer, float, and so on, then array name, then array size. So in data type here, integer, this integer, and the data type, data name is the numbers, scores, markers, names, and so on. And the array size will be 5 here. So this is declares an array named numbers that can hold 5 integers. So the 5 is the size of your array. So how are you gonna initialize the values? You can initialize an array upon declaration using curly braces. So again, if you look to this one, this is integer, it is the data type. This is array name, it's scores. It is depending on your own name of your data. This is the size. But at this site, we have two braces, two curly braces. This is the first one, the beginning, and this is last one. In between them, we described or stated our array values. So how many elements here? This 85, this is the element number 1, 92 element number 2, 78 element number 3, 96 element number 4, and 88, it is element number 5. This is element number 5. So these 5 elements representing the array size, what's written here. So the data of this array is 85, 92, 78, 96, 88. This is a representation of the simple array. Let us know how to let us say describe an array without specifying the size. This is a very important. The compiler can in this case, it means if you don't mention 5 as stated here, the compiler can automatically determine the size based of the number of initial value provided. Looking here, we haven't mentioned the array size here, only integer ages. Integer, again, is the data type. This is the array name. And between large braces, we haven't stated any size of an array. In this case, the compiler will automatically determine the size. So the ages, what we have here is 25. Let me pick the pen. We have 25, 30, 35, 28, 33. So this is indicators 5 elements. The compiler will automatically determine the size will be 5 as mentioned here. So regarding the partial initialization, sometimes this is the source of the mistakes or misunderstanding, let us say, doing by the student. if you look into this example, we have an example, integer grades. So integer is the data type, grade is the name of your array, 6 is the size of array. But at the right side, between the curly braces, we have only 3 values, 90, which is 90, 85, 77. So what about the 3 remaining arrays? In this case, 90, the value of 90 in this array, it is index 0. As you know, the array is a 0-based index. 85 is 1, 77 is 2, let us say. This is its index 2. So the index 3 and index 4, finally index 5 will be equal to 0. Why? Because it is values, the index of 3, it means grade of 3, it doesn't mention between the curly braces. This is what we call a partial initialization. Continue to the next parts. So if we want to access the values, even all of them, or individually, or single one, we can do it through a basic format of name and index. So in this point of a program, the array which should be visible, we can access the value of any of its elements, as I said before, individually, as if it was normal variable. Normal variable. So the format will be the name of the array. This is very important. Name your array, or let us say name your data. Let me pick the pen. Name your data, then index. Look, the index should be stated between the brackets, not the elements. Take care. Don't confuse between the elements and the index. The index should be stated here, or let us say in the array. Let us take an example. Let's take an example. If you look, this is actually not a table, but look like it's a table. This is I created in order to clear the array by you. If you look the blue row, it means the values looking, this is 10, then 20, 30, 40, and 50. This is the array values. So the array values, the 10, let us talk about the 10. Its element is 1. So the element number of value array of 10 is 1. This is the value, this is the element 1. So the element 1 contains the value of 10. But what is the index of this 10? As I stated in the first slide, it is zero-based index. The array is zero-based index, as the other parts of the C++ programming basics. So since the index is starting from the 0, it means the index of 10 here is 0, while its element is 1. Now, moving to array value 20. 20, its element is 2, while the index of 20 is 1. So starting from 0, where's the pen? Let me pick the pen. This is 0, this is 1, this is 2, this is 3, and this is finally 4. So index 4 of the value 50 equal to the element of 5. So it means that the element number always larger than the index number, since the element starting from the 1 while the index starting from the 0. This is very, very important in order to avoid the confusing, the mixing between them. So let us explain through an example. If you're looking to this example, you know at the beginning you are familiar with it. Here we started with in the array integer scores. It means, let us say, the marks. Then here in this example, I haven't mentioned the size of the array. At the same time, I can add the size, which is equal to, let us say, equal to, let me put that, equal to 5. The array size is 5. I can add this 5 here. But in this case, the compiler of the C++ will automatically determine based on what? Based on the provided your array values. I have provided 10, then 20, then 30, and 40, finally 50. So starting from the, let us say, 1, which is element, this is element number 1, number 2, number 3, number 4, number 5. So 5, you can write 5 here. If you don't want to mention, you can leave it free as I do it. And later, I will explain the n, let us say, will declaring the n integer n, and the result equal to 0. Mostly, the array comes with the looping. If you're looking there, I started with the 4. If n equal to 0 and n less than 5, the 5 which is the array size, n plus then plus. So since result mentioned here, I have, let us say, defined the equation of the result. The result equal to plus equal score, plus equal score. What does mean plus equal score? It look like as this explanation or this abbreviation, it look like as I will result equal to result plus score. So result equal to plus equal minus result equal to result plus score. Where's the score? It is comes from the array, starting from the 10, okay. 10 then is the first element, then the loop will stop if the n cannot continue or cannot execute such condition, n less than 5. So at the beginning, the compiler will take the 10. This is the first, let us say, element. 10, the first element. And then in the second iteration, the compiler will take the second element, which is 20. So since we said result equal to result plus score, at the first result equal to 0. Let me edit this one. The first result equal to the result we declared initially is 0 plus the first element is 10. This is the first iteration. The second iteration, the result will be, the result at the previous stage is 10 plus 0 equal to 10. While in the second iteration, the 10 in the first iteration plus second, let us say second item in the array, the second element. The second element is the 20. 10 plus 20 equal to 30. So second element is smaller or larger than the 5, which is described in the loop. So it is smaller. So the iteration will continue. Here, result equal to, so this is the third, let us say, iteration, equal to 10 plus 20 plus 30. In this case, how much would be equal to 60. If you continue the iteration, result equal to 10 plus 20, let us say directly the 60 of the previous iteration plus the fourth item, which is 40, equal to 100. Still the condition not met. We reached the fourth trial. So the compiler will continue result equal to 100 plus last element, looking to last element, which is 50, plus 50 equal to 150. So the first step is the iteration number 0, iteration number 2, number 3, number 4, and the number 5. At the number 5, we cannot go anymore, because if we try to continue, it will confusing to the condition, since there 1 is smaller than 5, 2 smaller than 5, 3 is also smaller than 5, 4 also smaller than 5, 5 are the same type. But if we go to the 6, the first problem is that we don't have 6, and the second is the let us say confusing with the condition which we mentioned should be less than 5. So from the 150 will be stop. That's why the result is 150. 150. Okay. Let's keep going. And let us erase all. We can valid, or we can, let us say, modify. We can more than one, let us say, syntaxes for validation the arrays. Same array, which is I talked before, but I'm talking here about some modifications, or let us say some validations. If I said, let us say, score 2, it means the score which has index of 2. The index of 2, looking there, the index of 2, the value will be 75. Its element is the third element. Again, don't make a confusing between the element number and the index number. So 75, its index is 2. That's why I written here score 2. We can also write the syntax are a equal to score 2. So score 2, all of equal to, or I will equalizing to the variable of a. So to store value of the third element to a variable a. So instead of 75, I will put a variable a small here. But take care, if you try to do such kind of, let us say, consideration or modifications, you have to remember your array should be at the same type. So your values, your component of your array should be unique and have the same, let's say, has the same data type. Integer score 5, it means a declaration of a new array, and so on. If you're looking the lecture, there is many such kind explaining such kind of modifications. Also, we can, if you're looking there, it means we can also write another variable b equal to score a plus 2. Another variable. This variable has its own let us say, index, plus index 2. Also, we can represent the index as a let us say a variable which is stated here. This is some examples of the validation operations of the array that we can perform during the programming. What we explained is the single array. Actually, array, there is two types of array: single and the multi-dimensional array. What I see, multi-dimensional is more applicable for us as a geomatics engineering, since it is dealing with the tables and matrices. So we can describe the multidimensional array is arrays of arrays. Arrays of arrays. Looking arrays of arrays. Perfect explanation. Arrays of arrays. So what is the arrays of arrays? Before talking about the multidimensional in the previous lectures, all arrays that we have is representing a single row. Single row. But from the multidimensional, this phenomena will be changed. It is no more singularization. So looking to this table, this table consisting of two rows. This is a first row. This is a first row. The first row has 3 columns. Column 1, column 2, column 3. Also, we have another row. This is a row number 2. For row number 2, also we have first column, second column, third column. So as a result, we have a table consisting of 2 rows with 3 columns. The first row starting from the index 0. Take care. Index 0. So the index of the first row starting from 0. This is not elementary. Take care. It is index number. So again, the same as the row, the tables, the columns starting from the 0. So this is the column number 0, the column number 1, the column number 2. While here, the row number 0. The way to declare this array, we will describe as a integer, the data type, and then array name. We have a table, depending on your own name. Then, which is the very, very important, at the single array, we have only one, let us say, double brace. Here, no, we have 2 double braces. The first one, I mean the 2 representing the row. How much the row you have in the table. While 3, which is written beside the 2, representing the column. It means you have 3 columns in the table. So this is all of representing a table with 2 rows and 3 columns. If you want to describe single value in the table, you can written in such a syntax. Table, it means the name of your table, then the row number starting from the considering index, then the column. So if I said table 1, 2 means the row number 1, the column number 2. Here is the column number 1, here is the column number 2. So this cell, this value, as I mentioned here, this value representing your value which you want to represent or access to it. So it's reference to the second element vertically. This is element number 1, element number 2. This is element. But 0, first element, you know, its index is 0. Second element, its index is 1. And the third horizontally. Third horizontally means third element horizontally. This is the element number 1, element number 2, element number 3. So from the second element vertically and the third element horizontally, you will reach this cell, which is we will write its syntax as a table row number considering let us say considering index number, then beside it the column number. Let me it is all what we mentioned. Then go to the let us this is example number 1. Example number 1 in the multi-dimension. In order to benefit from the time, let us say to avoid the waste of time, I am not going to compile through the Visual Basic or let us say any online compiler. You can do it. The codes are available in the lecture. You can do it as we previously did it in the campus. So imagine you have a table in this form. This is your table. Sorry. Imagine this is your table. Okay. You have a table consisting of 2 rows and 3 columns. How you can describe here? We have to describe at the beginning integer table 2, 3. Integer, it's the data type. Table, it is the array name, let us say. You can rename the table to the markers, to the scores. If you change the data type to the letters, for example, your group names, instead of the numbers, so integer here should be changed to the float, then your table name, then declaring the size of the table, your array, let us say. 2 is the number of rows, 3 is the number of columns, equal to, open the curly brace. Then you have to input your tables, 10, 20, 30, 10, 20, 30 as a first row, then entering second row, second element, it means index number 1, 40, 50, 60, then close the curly brace. Again, as I mentioned, most cases we are dealing with the for, it means looping in the array. I will put 2 loops, for the first for the rows, and the second for the columns. Okay, so integer I for always, I for rows, if integer I equal to 0, I less than 2. Take care, this condition, it means 2 is same as the row size, 2 here. Then I plus plus. For integer j, it is relating to the column equal to 0, then j should be less than 3. 3 again, the size of the column, j plus plus. So here's, we just want, this is a very simple example, just to show and to make a deep understanding from you about the multidimensional array. Just this is to print out, just for see out. See out table I and j. Then quotation, space, quotation. Finally, in order to make a tabular data in such a table, we have to, let us say, the right end line or backslash L in order to define a new line for each row, then return to 0. This is a very, very simple example. Let us erase this one, then continue. Again, this is same type of the multidimensional, just we change it, the declaration, instead of integer table 2 and 3, I here written integer table height and width. Height and width. Height denotes width denotes the column, height denotes the row. Declaration here, this is a loop for row and the column. In order to fill the table, I have put the equation n plus 1 multiply m plus 1, n for height, it means n for row, m for column, So applying such, let us say, equation, you will see your table will print out in such a way 1, 2, 3, 2, 4, 6. And this is, you can apply the numbers here, simply calculate this table. This is related to the matrix. It is same as tables. Instead, you will declare the matrix name. If it is changing, you can replace the integer to the floating or any data types. Same as tables looking. Same looping. Same print out 15, 25, 35. The first row of the matrix will start from 15, 25, 35. This is the first row. This is the second row. This is a second row of the matrix. 45, 55, 65. 45, looking the published or printed results. 45, 55, 60. This is 65. It's mistakenly becomes 66. Actually, this is this should also be 65, not 65, not 66, because we declared here 65 as a second row, third column. Moving to the application, you can write a program for calculate the leveling survey. We have such a leveling survey. The program will calculate for us height of instrument and the elevations automatically. You just input the backside, intermediate side, foresight, and the elevation of the first point. It will calculate for you the elevations. Its program has been written in the lecture. It's very easy. Just run it and input the numbers, what I have written. If we try to explain, it will take a lot of time. That's why I not compiling the, let us say, the code. As an assignment, you can repeat the programming of example 8, which is stated in the lecture. I will upload it to the system. Just the values has been changed. Hope you get benefit from this lecture, and wish you nice let me show a nice time.